All right, let's answer the question. What is the behavior of y equals to hyperbolic tangent? Some people call it van. I like to call it tang, so I'm going to read it that way. The tang of n sine of x. How does this thing behave? Okay, let's go ahead and graph it. If n is equal to 1, you can see that it's kind of going to resemble a sine function, as you can see right here. So before we actually observe this, we can take a look at what tang looks like. If you recall, the tang function resembles that of a inverse tangent function very well. It's just that instead of negative pi over 2 to pi over 2, it actually goes from negative 1 to positive 1, okay? And if you remember what sine functions looks like, let's actually do n sine of x. We know that it's simply going to be one of these shapes. And as n increases or decreases, you can see that the amplitude changes like that, okay? All right, so as you can imagine, it's going to be some sort of a mixture of these two where you can plug in n sine x into tang, and let's see what's going to happen. Y equals to tangent h of n sine of x. We already did the one case. Let's see what happens if it's equal to 2. Oh, it kind of looks a little bit blockier, right? How about a much bigger number like 17? It's getting even more blockier. So what's important to remember about the hyperbolic tangent is the fact that the upper and the lower bound of it, it's always going to be between negative 1 to 1. So no matter how large the input is going to be, um, tang is going to be between negative 1 to 1. However, because the input is periodic, you see a periodic shape in tang of n sine of x, and that's basically what's happening here. Let's see what happens if we use a very large number, for example, 10 factorial. You can see that the blocks are going to be almost perpendicular right here. And of course it's not, but I can imagine that these kind of functions can be very useful for things such as engineering and stuff. So I come from a mathematics or a statistics background, but so I've never really worked with this particularly, but I think it's a really cool function. So this is how tang of n sine of x behaves.